will start. Let them join. Okay. So I think I have stopped at stress corrosion. So what exactly is stress corrosion? As I discussed in the previous class, there will be some residual stresses that develop because of this uneven stresses. The corrosion that starts and propagates. So the best example is when you have any bend-shaped pipes. The bend-shaped pipes will be developed because of the uneven stresses. Because you might have given high stress here, maybe hitting with some hammer, and then there will be a lesser part where you does not have any hammering. So because of that, the stress will be developed in some place, and there will be no stress. And these uneven stresses is the one reason. The another reason could be the abrupt change in the velocities. See, the parallel flow of fluid may suddenly obstruct to a curved shape. So what will happen if the flow which is going horizontally suddenly obstructs because of the bend shape, suddenly obstructs, it tries to erode the surfaces. Because of that also, the stresses will be generated, and that stresses will lead to called stress corrosion. Okay, so that's what I have given a shape where this part, only this zone. You observe clearly that this zone is this bended part where it focuses or it faces the fluid velocity. See, suddenly the fluid velocity will focus this part only because there is a curved bend, suddenly making the flow of fluid to bend. Till this part it's a horizontal, but when it hits the surface, because it's already bent, this the flow of velocity should also bend. So what will happen if the fluid velocity, whatever the corrosive fluid, if it is going with very high velocity, it has to change the direction of the fluid movement. So the initial direction will be horizontal, but suddenly it obstructs, and then it changes its direction. Because of that, it tries to erode the surfaces. So that is what this portion. Okay. So that's what last time we have discussed. Solutions we will discuss at little later time. Yeah. The last out of 8 forms of corrosion is selective leaching. Look at, we have studied the leaching concept in mass transfer. What is leaching in mass transfer? What is leaching in mass transfer? There are quite a very good examples of leaching. In corrosion also, we have one type of corrosion called selective leaching. If you look at this, selective leaching is the removal of one element from a solid alloy by corrosion process. The best example is de-zinkification. That means zinc is removed or zinc is selectively leached out. It's called de-zinkification. How it will be done? You look at here. The example he has given. Selective leaching is the general term that describes this process. Yeah, de-zinkification. Look at here. Common yellow brass consists of approximately 30% of zinc and 70% copper. What is the brass? Brass is 30% zinc and 70% copper, which is in yellow color. Which is yellow color. What will happen in the de-zinkification? You can see a red color will form if zinc is removed, because 70% is copper in the brass. So if zinc is removed, the only part that is left with that alloy is a copper, and copper color is red. So this is what you can observe clearly, the de-zinkification, where formation of or left of only copper by removal of zinc. Okay. Maybe I have quoted one more example. Probably uh, there is another example I have quoted. This is the mechanism. You can look at the mechanism here. Commonly accepted mechanism is three steps. First, the brass dissolves. Next, the zinc ions stay in the solution, and slowly the copper plate backs on. So zinc will slowly get into the solutions. Fine. And I have given one more example for the, yeah, graphitization. Graphitization, that is cast iron containing the carbon. See, the cast iron appears to become graphitized in the surface layer. Fine, easily removed. This is one more, in the sense it also comes under the corrosion. That's why it is called graphite corrosion. Okay. How you remove? How you prevent the dezinkification? Is all given. See. Okay. We will talk about the removal or prevention methods at later part. Let us finish the concepts first. Yeah, reinforcement corrosion. Maybe it is not the eight forms of corrosion, but look at the corrosion in the concrete structures. See, when you have some pillars made up of like this, you see the iron rod or the steel rod, which we will be casting along with the concrete. Because of the moisture available, because of the oxygen penetration inside, it will get corroded quickly. And because the corrosion propagates, slowly it percolates and loses the surface and breaks the concrete molecules to separate out, and slowly the concrete structure entirely collapse. Okay. So this is the mechanism of this concrete reinforcement. But anyhow, we have not in the syllabus. But in general, I am talking about. Another is the hydrogen embrittlement. See, we discussed hydrogen, which perhaps seem to be good oxidizing agent. We discussed it. The H plus ions accepting the electrons. So hydrogen will also sometimes what will happen is absorbed on the surface and it percolates through the grain boundaries and dismantles the entire structure. And that is what this hydrogen embrittlement, it loses the structures. Fine. So there are a lot of examples for hydrogen embrittlement also. Corrosion of ship. And then the two ways I'll discuss about the stray current and all these things in two ways. Let's look at the overall picture of the corrosion. What we have discussed, the eight forms. Uniform attack, selective leaching, just now we discussed it. Removal of zinc from the brass, that is 70% copper, 30% zinc. This zinc is selectively removed. It's called dezincification. This is called selective leaching. Uniform attack we studied. Intergranular. Where is we study intergranular? Corrosion occurring at the grain boundaries. Inside grain boundaries, the corrosion occurs. Fine. And then galvanic, two metal coupling, galvanic. And then erosion. Just now we have seen erosion. And then pitting. Crevice corrosion, pitting corrosion, same sort of mechanism. What is the mechanism of pitting corrosion? What is the mechanism of crevice corrosion otherwise? When you have joints like this, so the joint where there is a depletion of oxygen, because by convection oxygen cannot pass because this is joined like this. So if there is no oxygen here, because the metal ions losing positive ion surface will be created, and this positive surface will attract the chlorine ions inside. So chlorine ions will definitely increase the corrosion sites. So in that way, the crevice corrosion or pitting corrosion will works. Okay, so it drives the chlorine ions to come inside because of depletion of the oxygen molecules. Okay, because by convection oxygen cannot enter into these rivets, these joints. This is what rivet. Okay, and then stress corrosion we have seen. So overall diagram, all forms of corrosion you see. Let's look at here. No corrosion. And there is a uniform corrosion. Means uniform means entire surface is uniformly removed. You see the size from here. It was this much of portion of surface is been removed completely. Now what is galvanic coupling? As I said, when two metals are in contact, depending on the electrochemical series, one will be protected, one will be corroded. Excuse me. What is erosion corrosion? Because of the high velocities, the surface will be eroded. So this is called erosion corrosion. There is another corrosion called corrosion fatigue, which comes under the cyclic stresses. Maybe if you remember in material science, creep and fatigue concepts. What is creep and fatigue concepts? Uh, Wherein if any material is undergone with several cycles. That's an example. Take a lorry. Let's look at the tire. So when a lorry load is moving from higher distances, what will happen to the tire? Tire is under severe cyclic stress. It has to rotate several kilometers. That means every time when rotation happens, one cycle it happens, it is under stress. Is it not? The tire is under stress because it has to rotate until unless we stop. We will put some brakes. So it is under severe cyclic stresses. So the corrosion developed due to severe cyclic stress is called corrosion fatigue. Fine. And then the crevasse corrosion, pitting corrosion. You see, look at the fittings, holes, the corrosion in the holes. So this is the overall forms of corrosion in a pictorial way. Okay. This is what you see. Cyclic stresses. They give a corrosion fatigue because it has been under stresses cyclically. I'm elongating, or rotating. Severe cyclic stresses. Maybe let us not discuss about the stainless steel at this moment. We will discuss. Yeah. Let's come to a concept called corrosion control. Let's devote this class completely for the corrosion control. In the previous class, I just left the selective leaching, so just I completed that. Now the next concept is corrosion control. Very important concept. How do we control the corrosion? We understood now till this part what we understood. What exactly the corrosion? Why iron corrodes? And then what are the types of corrosion? How many types of corrosion? Wet corrosion, dry corrosion. We discussed all the types of corrosions. We have seen the electrochemical series. We have seen electrode process. What is reference electrode? What is reference electrode? We discussed it. NHE or SHE, normal hydrogen electrode or standard hydrogen electrode. Fine. All we have discussed it. Now, even 8 forms of corrosion also we have discussed it. Whether is corrosion is happening uniformly or only in selective areas happening, that's called microscopic. Microscopic, not macroscopic, microscopic. Intergranular corrosion, crevice corrosion. Fine. Some corrosions you can see from your naked eye, some you cannot see. That's called microscopic corrosions. Okay, so crevice corrosion comes into that part because you cannot see. Is it not? Because the flanges are joined like this and the corrosion occurs inside this part. You cannot observe. So those all comes under the microscopic corrosions. Okay. Now the last part is how do you control the corrosion? Fine. Till now we understood there are some corrosions that are happening. Now how do you take preventive measures? This is what the corrosion control. We have number of methods. The first and foremost method is material selection. We have discussed this. Until and unless we are specific in material selection, we cannot control corrosion. As I said, if you are fabricating anything near seashore, so which type of metals you prescribe? Because any metal which is tend to corrode, you cannot prescribe there because lot of chlorine ions available, sodium plus ions are available. Fine. So many species are available which are highly oxidizing agents. They try to increase the corrosion rate. So we need to select a good material which combats the corrosion. So material selection is the first point, and then design. Design is required or not? Design is required. We have seen the surface area effect. What is surface area effect? SC by SC ratio. If I won't design properly, what will happen? Corrosion will be predominant because this SC by SC will be increased. If SC by SC will increase means IA will increase. IA means anodic current. Fine. So we always look at the surface area of the cathode and surface area of the anode should be the ratio should be, that is amplifying factor. Amplifying factor should be less. Protective coatings. Sometimes we often follow in our hometowns. In our houses, what we do in for example, I have a gate in my home. I want to see that it should not be get corroded. What I do? Because it's already designed. I cannot change the gate again. I cannot see how much area of cathode, how much area of anode. What I do, it's already erected, fabricated. So I just go by preventive methods of coatings. That's what paints, lacquers, enamels we do. Now inhibitors and environmental alterations. Sometimes what we do is we will go by some inhibitor methods. Inhibitors, we call inhibitors, which can inhibit the corrosion. And then environmental alterations. Sometimes we see make sure that the temperature or velocity in our limited regions. We will try to see in which place, for example, if a place where high movement of air is there, then erecting a acid production is not feasible, is it not? That's why if you look at in and around of Anantapur is a highly wind area. You see, that's why we have many windmills. Go to what we call in that Hindupur or Jones, you have a lot of windmills. The reason is a highly wind areas. So where the high flow of gases you can observe. So what will happen if high flow of gases are there? High flow of gases are there, they try to erode the surfaces, and if any corrosive fluids are there, they try to corrode. So we will always look at the environmental alterations, keeping very low velocity zones, not high temperature zones, not humid zones. Okay, and then lastly corrosion allowances. Even then, if we precautionally take all the measures, even then corrosion takes place. What is permissible levels, or how much is allowed? How do you rate the corrosion? MPY, mils per year. So how much is allowed? How many mils per year allowed? Okay, we will see all those things. So the first one is material selection. What type of material you select? Will you select a metal or a non-metal? Okay. Second one, coatings. In coatings also, there are some metallic coatings, inorganic coatings, organic coatings. So if you have gone to this Hindupur Berger times, you will look at all these type of coatings. They will show you the all metallic coatings, organic, inorganic, all types of varnishes. What are the unit of they might have look at if you go to the paint industry. And then design. Most important is the design. How do you design? See, avoid excessive stresses. What will happen if I allow the excessive stress? What will happen if I allow the excessive stress? It leads to stress corrosion. It leads to stress corrosion, is it not? See, if I see, for example, in my industry or in my production, let us say I have more YouTube bends of pipes. What will happen? Over a period, you have to shut down the industry because all YouTube V notches they will get corroded more fastly because the surface will be eroded off. If any high fluid velocity comes, the fluid velocity has to take the direction change. See, when I have some U shape like this, bent like this, the fluid velocity has to quickly change the direction. What will happen? Quickly change direction means they will hit, they impart all the kinetic energy to here because high velocity means high kinetic energy. So that fluid with high kinetic energy will hit the surface. That's why here there will be a block. That's what I showed you in the stress corrosion. You see a dome shape mass lesion out because it is hitting, it is imparting all the kinetic energy to the surface. So tries to take out surface. So the design is very important. Avoid excessive stresses. So don't use more types of bendings. Always prefer the pipes with a horizontal. But sometimes we need a bending because when in industry all the time you cannot go by straight pipes. For movements, for fluid transports, we should have some bending. But try to minimize the bendings because that will reduce your stresses. Second one, avoid dissimilar metal contacts. What will happen? Avoid dissimilar metal contacts. What will happen if dissimilar metals are contacted? What will happen if two metals are contacted, dissimilar metals? Galvanic corrosion takes place. What is the principle of galvanic corrosion? What is principle of galvanic corrosion? If two metals which are connected, which are in the electrochemical series up and down, what will happen? The upper metal will be acts as inert or anode or cathode, and then lower metal will be get corroded or active in the series. So we have to always look at when two metals are getting in contact, always choose the two metals are nearer in the series rather than two apart. What will happen if they are two apart? One will be saved, other will be damaged. See, if I want purposefully to do protect, I can do this. But unknowingly, if I do such type of contacts, what will happen? You're getting clear or not? See, నాకు కావాలని ఐరన్ ప్రొటెక్ట్ చేయాలంటే నేను ఐరన్ మెగ్నీషియంతో కనెక్ట్ చేస్తాను. దట్స్ వాట్ సాక్రిఫిస్ ల్యానర్ మెథడ్. బట్ ఇక్కడ నా ప్రొటెక్షన్ అది కాదు. అన్నోయింగ్లో నేను ఇలా ఏదో కలిపేసాను అనుకో ఏమవుతుంది? ఒకటి ప్రొటెక్ట్ అవుతుంది, ఒకటి కరోడ్ అవుతుంది. దట్స్ వాట్ గాల్వానిక్ కరోషన్. సో ఆల్వేస్ నేను ఏదైనా ఒక ఎరెక్ట్ చేస్తున్నప్పుడు ఆల్వేస్ హ్యావ్ టు ప్రిఫర్ ద మెటల్స్ విచ్ ఆర్ వెరీ క్లోజ్ ఇన్ ద సిరీస్. వెరీ క్లోజ్ ఉన్నప్పుడు ఏమవుతుంది? అప్ డౌన్ అనే కాన్సెప్ట్ ఉండదు. ఇట్లా దూరంగా ఉంటేనే ఓకే, అప్ ఇన్ ద ఎలక్ట్రికల్ సిరీస్, ఇనర్ట్, డౌన్ ద సిరీస్, యాక్టివ్, యానోడ్, cathode, corrode, free. But if we are very close enough, understood, in the electrical series, if they are very close, like one is up, one is below, which are very close, then the effect of this galvanic corrosion is very less. Clear? That is what avoid dissimilar metals. You understood cathodic, and I will tell you the anodic what is. Environmental control already we have discussed. The temperature, velocity, we have discussed these things. Is it not? Velocity, oxygen, effect of oxygen, oxygen concentration, oxidizers. We discussed it. Okay. Let's go one by one because it's a very important concept consisting of in the unit 2. Yes, proper design of the equipment. You see, the design of the equipment. More often time we will use baffles, valves, pumps. So when we are using all these things, always see elimination of crevices. If you won't eliminate crevice, what will happen? If you won't eliminate crevice, what will happen? Crevice corrosion will comes into picture. So what do you mean by elimination of crevices? This type of joints. This type of joints. So that means, for example, if I took these two, so this is one metal, this let us say. So this type of joints is called. So we should avoid this type of joints. Or if there is no choice, I have to go by these flanges. What I have to do? I have to put some inert materials. Is it not? I have to put some inert materials which cannot propagate the corrosion. So all the time people will go by weldings. What do you mean by welding? Welding. So they try to with a light, sparking light, they try to put the mass. They try to deposit some masses which can cover. So what will happen if I cover with some welding here? It will stop penetrating the other molecules to get in. Chlorine molecules లోపలికి వెళ్ళకుండా ఆపుతుంది. క్లోరిన్ కదా డ్యామేజ్ చేస్తుంది. క్రెవిస్ కరోజన్లో ఏంది క్లోరిన్? ఎందుకంటే ఈ పార్ట్లో మీకు ఆక్సిజన్ కాన్సన్ట్రేషన్ ఉండదు. క్లోరిన్ మైనస్ రావడానికి ట్రై చేస్తుంది. అదే మీరు ఇక్కడ ఒక మాస్ డిపాజిట్ చేస్తారనుకో వెల్డింగ్ చేసేసి, ఏమవుతుంది అంతా వెల్డింగ్ చేస్తే ఉండదు. సో ఇన్ దట్ వే యూ హ్యావ్ టు ప్రివెంట్, ఎలిమినేట్ ది క్రెవిసెస్. కంప్లీట్ డ్రైనేజ్ ఆఫ్ ద లిక్విడ్స్. దేనికి అంటే ఒక పైప్, ఒక ఎక్విప్మెంట్ ఉందనుకోండి, ఒక ట్యాంక్ ఉందనుకోండి, కంప్లీట్గా డ్రైన్ చేయాలి. ఎందుకు డ్రైన్ చేయాలి? కొద్దిగా లిక్విడ్ ఉన్నా చాలు కదండి కరోజన్ అవ్వడానికి. బికాజ్ వీఆర్ ఎనీవే గోయింగ్ విత్ ద ఐరన్ పైప్స్, ఐరన్ ట్యాంక్స్ ఆర్ స్టీల్ ట్యాంక్స్. సో వాటర్ మాలిక్యూల్స్ దొరికితే చాలు కదా. సో ఆల్వేస్ 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 డ్రైన్ ది లిక్విడ్స్. లిక్విడ్స్ ఇన్ ద సెన్స్ దట్ లిక్విడ్ మే బి అన్ యాసిడ్. సల్ఫ్యూరిక్ యాసిడ్ మీరు ప్లాంట్ చూస్తుంటే అర్థమవుతుంది. ఇంత పెద్ద పెద్ద వాల్యూమ్స్ ఆఫ్ ట్యాంక్స్ ఉంటాయి. మరి సల్ఫ్యూరిక్ యాసిడ్ ఎంత హైలీ ఎసిడిక్, హైలీ ఆక్సిడైజింగ్. స్టీల్ని కూడా కరోడ్ చేసి పడేస్తుంది. స్టీల్ని కూడా కరోడ్ చేసి పడేస్తుంది. మరి నువ్వు కొద్దిగా వదిలేసావు అనుకో, అక్కడ ఆ మూల ఈ మూల కొద్దిగా యాసిడ్ వదిలేసావు ఏమవుతుంది? సో వీ నీడ్ టు కంప్లీట్లీ డ్రైన్ ద లిక్విడ్. ఇట్ షుడ్ బి ఈజీ టు క్లీన్. ఎందుకు ఈజీ టు క్లీన్? ఇప్పుడు నా దగ్గర ట్యాంక్ ఉంది, దాన్ని నేను క్లీన్ చేయడానికి అవకాశం లేదనుకో ఏమవుతుంది? కరోడ్ అవుతుంది కదా. ఎప్పటికప్పుడు నేను క్లీన్ చేసుకుంటూ ఉండాలి. ఆ లోపల ఉన్న లిక్విడ్ని, లోపల ఉన్న సాలిడ్ మాస్ని తీసేస్తూ ఉండాలి. ఓకే, డ్రైనేజ్ ట్యాంక్స్ ఉంటాయి. ఎందుకు దాని మీద క్యాప్ పెడతారు? అట్లా లోపల ఒక మనిషి వెళ్ళి క్లీన్ చేయడానికి. సింటెక్స్ ట్యాంకులు ఉన్నాయి ఓవర్ హెడ్లో. మనకి ఏం చేస్తాము? నెలకోసారో 6 నెలలకోసారో క్లీన్ చేస్తాము. ఎందుకు? మట్టి పేరుకుపోయి ఉంటుంది, మట్టి పేరుకుపోయి ఉంటుంది, చెత్త పేరుకుపోయి ఉంటుంది. క్లీన్ చేయకపోతే ఏమవుతుంది? నార్మల్ వాటర్ అయితే వాటర్ కంటామినేట్ అవుతుంది, కరోజివ్ యాసిడ్స్ అయితే కరోజన్ అవుతుంది. అంతే కదా. యాసిడ్ ట్యాంక్ ఉంది, నేను కనుక క్లీనింగ్కి అవకాశం ఇవ్వలేదనుకో, అంటే నేను ఒక మనిషి వెళ్ళడానికి లేకపోతే ఒక బ్రష్ లోపలికి వెళ్ళడానికి అవకాశం లేకుండా నేను ట్యాంక్ డిజైన్ చేశాను అనుకోండి, ఏమవుతుంది? Definitely, the small amounts of acids left will try to start corrosion. So easy to clean. Facilitate easy access to inspection and maintenance. నేను ఫెసిలిటేట్ చేయాలి, మెయింటెనెన్స్ చేయడానికి, క్లీన్ చేయడానికి, ఇన్స్పెక్షన్ చేయడానికి ఈజీ యాక్సెస్ ఇవ్వాలి నేను. ఇవన్నీ డిజైన్ కాన్సెప్ట్స్. అంటే నేను ఒక ఎక్విప్మెంట్ డిజైన్ చేస్తున్నప్పుడు ఇవన్నీ ప్రికాషనరీ మెథడ్స్ తీసుకోవాలి. లాస్ట్ వన్, అవాయిడ్ బయోమెట్రిక్ కాంటాక్ట్స్. ఇదిగో చెప్పాను ఇప్పుడే, బయోమెట్రిక్ కాంటాక్ట్స్ అవాయిడ్ చేయాలి నేను. ఒకవేళ చేయలేదనుకో జాగ్రత్తగా చూసుకోవాలి, దగ్గర ఉన్నట్టు చూసుకోవాలి. అదే రెండు మెటల్స్ని అక్కడ మీద ఒక సిరీస్ ఇక్కడ కింద సిరీస్ పెట్టుకున్నాను అనుకో, మెటల్స్ని బయోమెటల్ చేసాను అనుకో, ఏమవుతుంది? ఇందాక కేసులో బ్రాస్ జింక్ ఏమైంది? 30% జింక్, 70% కాపర్. స్లోగా జింక్ వెళ్ళిపోద్ది సొల్యూషన్లోకి, డీజింకిఫికేషన్. ఎందుకంటే జింకు కాపర్ సిరీస్లో దూరంగా ఉంటాయి. అదే దగ్గరగా ఉన్న సిరీస్లో పెట్టుకున్నాను అనుకో బయోమెటాలిక్ పర్లేదు, అప్ డౌన్ అనే కాన్సెప్ట్ రాదు. దూరం ఉన్నాయనుకోండి. ఇన్సులేషన్ ఆఫ్ ద జాయింట్స్ ఇప్పుడే చెప్పండి. వెల్డింగ్, వెల్డింగ్ ఎందుకు చేస్తాము? ఇదే ప్రివెంటింగ్ ది కరోజన్స్. ఓకే, look at here. Choice of materials for corrosive environments. అంటే in which type of environment which metal should be chosen. Easy. When castic solutions are there, that means whenever any alkali are there, always go by nickel alloys. HF, hydrofluoric acid, choose monal metal. Hydrochloric acid, choose Hest alloys. Nitric acid, choose stainless steel. సో ఎక్కడన్నా నైట్రిక్ యాసిడ్ ప్లాంట్స్ చూస్తే ఖచ్చితంగా స్టెయిన్లెస్ స్టీల్ వాడతారు. ఎందుకంటే నైట్రిక్ యాసిడ్లో స్టెయిన్లెస్ స్టీల్ కంప్లీట్గా ప్యాసివ్ లేయర్ ఫామ్ అవుతుంది. మీకు కావాలంటే మనం ఆల్రెడీ అక్కడ డిస్కస్ చేసాం, ఒకసారి మీకు చూపిస్తా. మీకు వాట్ వి కాల్ ఎఫెక్ట్ ఆఫ్ వేరియస్ పారామీటర్స్ దగ్గర నేను మాట్లాడాను. మీకు ఎగ్జాంపుల్స్ కూడా ఇచ్చాను. డిఫరెంట్ కాన్సెప్ట్స్ దగ్గర మనం మాట్లాడాము. ఒకసారి మీకు అది చూపిస్తే మీకు అర్థమవుతుంది. ఇక్కడ చూడండి. ఇక్కడ వాట్ ఈజ్ జోన్ 2? యాసిడ్. జోన్ 2కి ఎగ్జాంపుల్ చూడండి. క్రోమియం నికెల్ ఇన్ నైట్రిక్ యాసిడ్. క్రోమియం నికెల్ అంటే స్టెయిన్లెస్ స్టీల్. స్టెయిన్లెస్ స్టీల్ ఇన్ నైట్రిక్ యాసిడ్, యాసిడ్ జోన్. సో కరోజన్ పెరగదు, ఎందుకంటే ఆక్సైడ్ లేయర్ ఫామ్ అవుతుంది. సో నైట్రిక్ యాసిడ్ ఎప్పుడు ఉన్నప్పుడు యూ హ్యావ్ టు గో బై స్టెయిన్లెస్ స్టీల్స్ ఓన్లీ. క్లియర్? సో అందుకోసమే ఏ ఎన్విరాన్మెంట్లో ఏ మెటల్ చూస్ చేసుకోవాలి, దట్ ఈస్ ద డిజైన్ ప్రిన్సిపల్. సో వెన్ ఎవర్ నైట్రిక్ యాసిడ్ ఇస్ దేర్, choose stainless steel only. Hydrofluoric acid is there, choose monal alloy only, Hest alloys only. So that is what the design. అలాగే ఇక్కడ ఇంకొకటి చూపిస్తాను మీకు. ప్రాబబ్లీ maybe should corrosive. Look at the corrosive example. Corrosive, lead in sulfuric acid. Lead in sulfuric acid ఏంటి ప్రిన్సిపల్ ఇక్కడ? if you look at lead in sulfuric acid, let it try to form the solubilase or the factors. I can show you the factors. Lead sulfate, it forms. Parameters. Yeah, here. Look at here. The I have kept here the solubility of corrosion products. Look at the statement. Lead in sulfuric acid forms lead sulfate, which is insoluble. That means what? If I keep lead in sulfuric acid, it forms lead sulfate, which is insoluble. That means this layer will be there. If this layer will be there, means what? Its corrosion is inhibiting. It is not making the other species to enter. So this is example I want to show you here. Yeah, here. You see here? Yeah. You see sulfuric acid, lead. So whenever lead, sulfuric acid is there, choose lead materials because lead will what will happen? Lead will solubilize in sulfuric acid to form lead sulfate, which is insoluble. That means this sulfate layer will be there. If that oxide layer or sulfate layer will be there, it will not pass the molecules to react with the lead surface. Okay. So when strong oxidizing agents are there, always choose titanium. That is why whenever our teeth broken, doctors prescribe to go by titanium teeth. So why they prefer titanium teeth? Not the golden teeth. Gold teeth will be Ambani can do. We people won't go by the gold teeth. But it's always preferable to go by titanium teeth because in our mouth highly oxidizing, highly acidic in nature our mouth. If you open the mouth, we have lot of pH inside. So only titanium can attack. Titanium can only prevent the corrosion. Otherwise, what will happen? Slowly, this teeth will damage. Cracks will form. Okay. Yeah. What is the general rules? You see the rules. Always go by boiler waters. Why they won't prefer normal waters? Normal water quickly splits into H plus and OH minus, and H plus is oxidizing in nature. So if I take boiler waters, which is in a vapor state, water in a vapor state, so I can have reduced the corrosive. So always these are the approaches and for the processes. You see here, I kept for extremely powerful oxidizing conditions, go with the titanium. Last sentence. Extremely corrosive conditions, oxidation conditions, go always, choose always titanium. Understood now? So for caustic solutions, what is the metal we have to choose? Nickel. Sulfuric acid, lead, nitric acid, stainless steel. So we have to remember these things. Whenever we are going for any what we call design for any industry or any equipment, we have to look at these things. Whenever hydrofluoric acid is there, we have to go by haste alloys only. Even if you know hydrofluoric acid will eat the glass also. HF, highly what we call oxidizing agent. That's why we won't take hydrofluoric acid in the glass tubes. మీరు అబ్జర్వ్ చేయండి ఎప్పుడైనా హైడ్రోఫ్లోరిక్ యాసిడ్ని మీరు ఎప్పుడైనా అఫ్ కోర్స్ మనకి ఎక్స్పెరిమెంట్స్ ఏం లేవు హైడ్రోఫ్లోరిక్ యాసిడ్లో బట్ హైడ్రోఫ్లోరిక్ యాసిడ్ని మీరు ఎప్పుడు వాట్ వి కాల్ ఈ రౌండ్ బాటమ్ ఫ్లాస్క్లో తీసుకోము, టాషన్ ట్యూబ్లో తీసుకోము, పిప్పెట్లో తీసుకోము. ఏమవుతుంది తీసుకుంటే? తినేస్తుంది, గ్లాస్ని కూడా తినేస్తుంది. ఇట్ విల్ హెచ్ అవుట్ ది గ్లాస్. హైడ్రోఫ్లోరిక్ యాసిడ్ ఈవెన్ హెచ్ అవుట్ ది గ్లాస్ని కూడా తినేస్తుంది. అందువల్ల hydrofluoric acid cannot be catched out. So we always have haste alloys. Okay. Now look at the next thing. What type of corrosion? What is the prevention strategy? You see here, for example, if the stress corrosion, what is the strategy we will follow? For stress corrosion, always use, try to see, remove the tensile stresses. Try to see, eliminate the chlorides. For corrosion fatigue, try to eliminate the cyclic stresses. Galvanic corrosion, try to choose the metals which are very close. Crevasse corrosion tries to proper design of the junctions and joints which minimizes the crevasses. Okay. Erosion corrosion, try to reduce the velocity. Fine. Try to reduce the velocity or turbulence. Avoid abrupt changes in the flow directions. Fine. Coatings. Okay, what do you mean by coatings? What do you mean by coatings? You will try to have a sort of layer onto the surface. That's what the coating. So that is a barrier between the environment and the metal. Is it not? See, if I want to coat something here, this is my environment and this is my metal. So if I coat something, that will be a barrier for the metal and the environment. So that environmental species cannot attack the surface. Barrier means it will not pass. So that coatings may be metal coatings. Metal coatings means, look at the metal coatings. Silver, copper, nickel, chromium. Sometimes sacrificial coatings. We already seen zinc coating, zinc galvanizing we call as. Okay. Aluminium, stainless steel, titanium. And sometimes other types of treatments, surface treatments also there. What are the other types? Modification of the substrates to ion implantation. There are ion implantation techniques also there. Okay, anodizing, chromate, phosphatizing, sometimes organic coatings. What are organic coatings? You see the paints is organic coating, paints, crackers, varnishes. Okay, I have given here the types of paints. Even in the paints also there are different types. You see, lacquer, synthetic resins, latex, copolymic protective coatings, anti-corrosion paints. Now we have in the market anti-corrosion paints. Fine. It's like anti-pest control. So there are some coatings which will control the pest like anti-corrosion. So metallic coatings. So always we choose more noble metals in the type of metallic coatings. Okay. So what are the factors that must be considered in selection of a coating metal? The coating should be able to resist direct attack of the environment. The coating should be non-porous and continuous, no cracks. What will happen if a crack is developed during the coating? See, if I coat something, let us say if crack is developed, what will happen? So that crack will propagate. That is what the problem. See, when crack initiates, it propagates. It gives channels for passes. Is it not? See, for example, you have some path here, and if there is a path, definitely that path is giving direction for the species to move inside. Is it not? చిన్న క్రాక్ వచ్చింది అనుకోండి, క్రాక్ వచ్చిందంటే అర్థం ఏంటి? అదొక ఒక రూట్ ఇస్తుంది. సో హెచ్ మాలిక్యూల్స్, హెచ్ ప్లస్ అయాన్స్, ఫారెన్ కూలర్మెన్స్ అయాన్స్ అవన్నీ ఏమవుతాయి? ఆ గ్రెయిన్ బౌండరీస్లో ఆ పాత్లో ట్రావెల్ చేసుకుంటే లోపలికి దూసుకెళ్ళిపోతాయి. ఇంకేముంది లోపలికి వెళ్ళిపోతే? సర్ఫేస్ లోపలికి వెళ్ళిపోయింది అనుకోండి, బల్క్లోకి వెళ్ళిపోయింది అనుకోండి, కరెక్ట్గా ఎక్కడ కూర్చోాలో అక్కడ కూర్చుంటుంది, కరోజన్ స్టార్ట్ చేస్తుంది. ఓకే. సో దట్ ఈస్ వాట్ వీ హ్యావ్ టు అవాయిడ్ దోస్ టైప్ ఆఫ్ క్రాక్స్ ఫస్ట్. సో క్రాక్ ఫ్రీ అంటాం దాన్ని. electroplating. We apply some potential to deposit the materials. ఓకే, అదే జింక్ గ్యాల్వనైజింగ్ అవంతా దాంట్లోకి వస్తుంది, ఎలక్ట్రోప్లేటింగ్కి వస్తుంది. నాన్ మెటాలిక్ కోటింగ్స్, అదే ఇప్పుడు మనం మాట్లాడే నాన్ మెటాలిక్ కోటింగ్స్ అంటే ఈ ఆర్గానిక్ కోటింగ్స్ అన్నీ వచ్చేస్తాయి దాంట్లోకి. ఫాస్ఫేటింగ్ కూడా ఇన్ఆర్గానిక్ పెయింటింగ్. అంటే ఏంటి, ఐరన్ ఫాస్ఫేట్ యూస్ చేసి ఐరన్ ఫాస్ఫేట్ ఫిల్మ్ వేస్తారు. ఎనామిల్స్, ఈవెన్ సమ్టైమ్స్ సిమెంట్ కోటింగ్ కూడా. లుక్ ఎట్ హియర్, used to coat the inner side of steel pipelines carrying water or waste water. నిన్న మొన్న పేపర్ చూస్తుంటే గుజరాత్లో రోడ్డు వేశారంట, స్టీల్ రోడ్డు వేశారంట. అంటే స్టీల్ ఇండస్ట్రీస్ నుంచి వచ్చే వేస్ట్ని తీసుకొని రోడ్డు వేశారు. దట్ ఈస్ ద ఫస్ట్ ప్లేస్ ఇన్ ఎంటైర్ ఇండియా వేర్ అవుట్ ఆఫ్ వేస్ట్ ఫ్రమ్ ద స్టీల్ యూజ్డ్ టు పుట్ ది రోడ్. యూజువల్గా మనం వాడేది ఏంటి, రోడ్ మెటీరియల్ తార్. సో వాళ్ళు తార్ వాళ్ళే స్టీల్ ఇండస్ట్రీలో వచ్చిన వేస్ట్ని తీసుకొచ్చి, ఎందుకంటే అక్కడ వాళ్ళకి స్టీల్ ఇండస్ట్రీ ఉంది గుజరాత్లో. సో ఆ స్టీల్ ఇండస్ట్రీ నుంచి వచ్చిన వేస్ట్ అంతా తీసుకొచ్చి దే ప్రిపేర్డ్ ఏ మాస్ అండ్ దట్ ఈస్ నౌ సస్టైనింగ్ యాజ్ ఎ మెటీరియల్ ఫర్ ది రోడ్ మ్యానుఫ్యాక్చర్. సో వన్ మోర్ ఇన్వెన్షన్, దట్ మీన్స్ వాట్, యు ఆర్ రెడ్యూసింగ్ యువర్ తార్ యూసేజ్. చాలా కాస్ట్ తారు కొనుక్కుంటే కదా, ఇప్పుడు కొనుక్కునే అవసరం లేదు. ఇప్పుడు అది సక్సెస్ అయింది, చాలా లోడ్స్ విత్స్టాండ్ అవుతుంది. ఇప్పుడు రోడ్ వేయడం ఇంపార్టెంట్ కాదు, రోడ్డు వెయిట్ని విత్స్టాండ్ చేయాలి. ఇప్పుడు నేను ఒక 10 లారీలు పంపించాను అనుకోండి లోడ్ని, అది క్రాక్లు కాకుండా కిందకి దిగిపోకుండా ఉండాలి ఆ రోడ్డు. సో అది సస్టైన్ అయింది. సో దట్ షోస్ ది గుడ్ yield strengths, ultimate tensile strengths. So now people will turn up to use this steel wastes for road manufacture. Okay, organic coatings, paints, so pigment, resin, solvent. So I have given some primers also, because you might have studied in chemical technology class. Primer, what is primer? Is a paint coating containing a pigment such as lead oxide or zinc chromate which oxidizes the steel surface and inhibits its corrosion. The primer film increases the strength of the bond between steel and the final paint film. Okay, so and then down is the lacquers. So I given collection, and then lastly corrosion inhibitors. What do you mean by corrosion inhibitors? So there are some substances which in small amounts if you add it will inhibit the corrosion. So one of my project students are working on this corrosion inhibition. So I suggested for one plant. That plant had some phytochemicals which will act as a corrosion inhibitors. So if I add small amount of that plant extract into my solution, into my acid solution, even if I dip stainless steel into the acid solution, that will not corrode, because the species which I added will act as corrosion inhibitors. So my batch students are working on that corrosion inhibition studies. Fine. So small amounts if you add, it will stop further increase of this corrosion. So again, the types of inhibitors classification: inorganic or organic. Again in the inorganic, anodic inhibitors, cathodic inhibitors. So there is a vast study. So at least over periphery of knowledge, if it is required, that is also enough. Okay. So cathodic inhibitor, sometimes we go by some compounds like zinc sulfate, magnesium sulfate. They are all act as a cathodic inhibitor. Sometimes oxygen scavengers. Look at the oxygen scavenger. See, these are the compounds which react with the dissolved oxygen and remove it from the neutral or alkaline corrosion environments. Best examples are sodium sulfide, hydrogen. Look at the hydrogen. It takes away the oxygen. It's called oxygen scavengers. సో ఆక్సిజన్ తీసేస్తే ఏమవుతుంది, కరోజన్ తగ్గించినట్లే కదా. ఎందుకంటే కరోజన్లో నాకు కావాల్సింది ఏంటి, మెయిన్ ఇంపార్టెంట్ కన్స్టెంట్స్ వాటర్ మాలిక్యూల్, ఆక్సిజన్, ఎలక్ట్రాన్స్. సో ఇఫ్ ఐ రిమూవ్ వన్ ఆఫ్ ది స్పీసీస్ ఆక్సిజన్, ఐఎమ్ indirectly controlling the corrosion. So oxygen scavengers. So whenever oxygen is there on the surface, these type of molecules will take away that oxygen. It's called eat away oxygen. That's called oxygen scavengers. So those will fall under the cathodic inhibitors. Okay. So compounds such as arsenic, mercury, antimony, they slow down the cathodic hydrogen evolution reaction. Sometimes adsorption inhibitors. Some compounds which contain the polar group, amino group, they will adsorb on the surface and they try to reduce the corrosion. So these are called adsorption inhibitors. Okay. So look at the prevention of corrosion. I have put out here, but I have put some design concepts. Yeah, this is very important. 8 engineering design rules that are important to reduce or prevent the corrosion. Like 8 forms of corrosion I have given. This is the 8 design rules for corrosion control. You see, whatever we have discussed, all are there. See, avoid excessive stress. If possible, use more closely the galvanic coupling of materials. The 8 points only I have kept in 8 points like this. See, avoid sharp bends. Avoid sharp bends in piping. What will happen if I won't ever? If I won't ever, what will happen? Stress corrosion. Is it not? Erosion corrosion. So always avoid the sharp bendings. Design tanks and other containers for easy draining and cleaning. We discussed it. What will happen if it is not easily cleaned or drained properly? What will happen? It left out amounts of liquids. They try to start corrosion. And sometimes if it is an acid, the the proximity of corrosion will be much more higher. See, design heating systems such as hot spots, avoid the contacts, use proper material, highly oxidizing environments go by titanium only. So these are the 8 important design rules in preventing the corrosion. Okay. So you can go by the what we call the coatings. That coatings may be organic coatings, inorganic coatings, or you can go by the inhibitors, either organic inhibitors, inorganic inhibitors, anodic inhibitors, cathodic inhibitors. Okay, or you can choose the design properly, material selection. So these are all comes under this corrosion prevention control. Is it clear? Fine. So only part that is left is I can show you the anodic control. I'll just go back because that is the only part that is left. Let's complete that part so that I'll leave. So just a small part where just small principle. See, because I have left here, whenever cathodic protection is there, you should also know what is anodic protection. Yeah, here. See, we know what is this sacrificial anode method. What is sacrificial anode method? Contacting magnesium or zinc rod to the iron because which are in the a part of the in the electrical series. This is called sacrificial anode method or cathodic protection. Now another method called anodic protection. What we do is in anodic protection, we try to choose some metals in the periodic table, mostly platinum or such metals, and we try to manipulate the potential and currents such that we will fall in the what is Kohlberg's diagram we discussed. What we discussed in the Kohlberg's diagram. There is a pH on the x-axis and the potential on the y-axis, and there will be 3 zones: immunity zone, corrosion zone, passive zone. So if I just change the pH or the potential, you will fall either in the immunity zone or corrosion zone or passive zone. So if my pH or potential such a way that if I am safer in the immunity, fine. Or if I fall in the corrosion, I will be in corrosion only. If I make it to fall in the passive zone, your corrosion is inhibiting or not. So that is what I can do. I can manipulate the current and potential such that I will fall in the passive zone where oxide layer will be formed, corrosion can be prevented. So this is what anodic protection by manipulating the currents. You can control the corrosion. Okay, so what the materials we will use, mostly we will go by what we call platinum. Okay, now let us see another method which is called impressed current cathode protection. Impressed current cathode protection. What is this impressed current cathode protection means? With sort of either external battery or amplifier, I will supply some current or electricity to the underground pipe, and this excess electrons will be taken up by the oxygen molecules for OH minus ion formation. What is the actual principle of corrosion we discussed? For iron corrosion, iron first loses two electrons to form Fe2 plus, and the two electrons were taken by the oxygen molecules to form OH minus. Then OH minus will react to form Fe2 plus to form FeOH. So this oxygen is taking electrons from the metal because Fe losing Fe2 plus two electrons. What I am here doing is, instead of taking the electrons from the metal, if I supply external electrons to this one, that external electrons only can take up this reaction, not the metal losing electrons. Are you getting or not? See, for example, let's talk in a more general way. I am losing money because someone is there to pick the money. I will lose. Is it not? For example, there is a one boy is there, and he is devoted to take the money from all the time. So I am taking 10 rupees, 10 rupees, 10 rupees. So Fe is losing two electrons, two electrons, two electrons. But instead of I am taking money from my pocket, let us suppose there is external body here which is giving money to me. Instead of going from my pocket, let us say I am getting money from in this hand. If this hand I have money, this boy is only takes the money. He won't bother about whether it is coming from my pocket or from other agency. So this boy is fixed taking the electrons. Now instead of taking electrons from my pocket, if some other party is there which is giving amount, so this boy will always take the amount only, whether it is from here or here. Like this, instead of taking the electrons from the metal, if external electrons, if I am supplying, that electrons only will be taken by the oxygen molecules. Then what about the metal? It will be as it is only, it won't lose. Is it not? Or it will lose only certain extent, but not the extent that this bar is taking. This is called impressed current cathode protection. మీకు అర్థమైనట్టు అనుకుంటాను. మెటల్ నుంచి ఎలక్ట్రాన్స్ తీసుకోకుండా పై నుంచి పంపిస్తున్నాం. ఒక యాంప్లిఫైయర్ పెట్టి లేదంటే ఒక డీసీ ఒక బ్యాటరీ పెట్టి బ్యాటరీ నుంచి బయట నుంచి ఎలక్ట్రాన్స్ పంపిస్తున్నాం. సో సర్ఫేస్ మీద ఎలక్ట్రాన్స్ బయట నుంచి ఎలక్ట్రాన్స్, మెటల్ లూజర్ ఎలక్ట్రాన్స్ కాదు. ఆక్సిజన్ కావాల్సిన ఎలక్ట్రాన్సే, మెటల్ నుంచి వచ్చిందా బయట నుంచి ఇచ్చామో దానికి అనవసరం. ఈ రకంగా నేను ప్రొటెక్ట్ చేయగలుగుతున్నాను. ఇట్స్ కాల్డ్ impressed current cathodic protection. Externally I am sending the current. That current is called impressed current. Okay.